In section 6.5, we're solving equations containing rational expressions. In this section, we will solve equations containing rational expressions. Before beginning this section, make sure you understand the difference between an equation and an expression. An equation contains an equal sign, whereas an expression does not. That is the only thing that is different between an equation and an expression. Equations have equal signs. To solve equations containing rational expressions, we first clear the equations of fractions by multiplying both sides of the equation by the LCD of all rational expressions. Then solve as usual. Recall that a rational expression is undefined for values of the variable that make the denominator 0. If a proposed solution makes the denominator 0, then it must be rejected as a solution of the original equation. Such proposed solutions are called extraneous solutions. So the steps to solve an equation containing rational expressions: you multiply both sides of the equation by the LCD of all rational expressions in the equation. You simplify both sides. You determine whether the equation is linear, quadratic, or higher degree and solve accordingly. And check the solution in the original equation. So let's go ahead and try this with example number 1. We want to solve 3 over x minus x plus 21 over 3x equals 5/3. So the first thing we have to do is to find the LCD. So my denominators include an x, a 3 times x, and a 3. So the LCD is 3x. And so looking at that, what value of x would cause 3x to be 0? If I were to plug in x equals 0, my 3x would turn into 0, which we can't have in the denominator. So the one value we are not allowed to have is x equals 0. We're just going to keep that to the side until the end when we check our solutions to make sure none of them are extraneous. So what we want to do now is we're going to multiply each and every piece of our equation by 3x. So we have 3x times 3 over x. We have 3x times x plus 21 over 3x. And I am going to go ahead and put parentheses around x plus 21. And we also have that 3x times 5/3. And so when we do this, we're going to use cross multiplication to cancel out all of the denominators. So the x on the bottom is going to cancel with the x in the 3x. The 3x on the bottom cancels with the 3x on the top. And the 3 on the bottom cancels with the 3 in the 3x. And so this has been simplified a lot. We have 3 times 3 left over in the first term. Then we have a minus 1 times x plus 21. And then we have x times 5, which is just going to give me 5x. And so let's just go ahead and simplify this a little bit. We're going to be able to distribute that negative to both pieces. And what we end up on the left is 9 minus x minus 21 equals 5x. And from here we can solve this easily. So on the left we want to make sure we combine like terms. We have a 9 and a negative 21, which is going to give me negative 12, minus x equals 5x. And so we want to get all of our x's to one side. I am going to add x to both sides. So it ends up canceling on the left. We have negative 12 equals 6x. And solving for x, we're going to divide by 6 on both sides. And we end up with x equals negative 2. Once we've gotten an answer for x, or answers for x, we want to make sure that it doesn't contradict what we said x was not allowed to be. So once we're done, we just go ahead and compare it with what I said I could not have, which was 0. And since it's not 0, we can accept this as our solution. So x equals negative 2. Let's go ahead and try another one. So for example number 2, the first thing we want to do is find the LCD. Well, the LCD is pretty easy in this case because we have the same denominator on both sides. So that's going to be the LCD. It's going to be x minus 2. The next step is to see what value of x would cause x minus 2 to be 0. So if I set it to 0 really quick, I would end up with x equals 2, and that would be the value that I am not allowed to have. And so I'm going to multiply both sides by x minus 2. So we have x minus 2 times x plus 6 over x minus 2. And I'm going to have x minus 2 times 2 times x plus 2 over x minus 2. So again, when I do this and I cross multiply, the x minus 2 and the x minus 2 cancel, and the x minus 2 and the x minus 2 cancel. And so I'm just left with the numerators in this case, which is x plus 6 equals 2 times x plus 2. Now we can solve this as we have been in previous sections. We're going to distribute the 2, and we end up getting x plus 6 equals 2x plus 4. We want to get our x's to one side and our constants to the other. So I'm going to subtract x from both sides. And so on the left, they cancel. And we have 6 equals x plus 4. And then we want to subtract 4 from both sides to get x by itself. And we end up with x equals 2. Once you get your answer, you just have to make sure that you compare it with your little bubble that you made at the beginning. Well, I got x equals 2, but I said that the only value of x I'm not allowed to have was 2. So because this violates that condition, we're going to throw it out. And since I have no other solutions to pick from, the answer is going to be no solution. Let's try another one. For example number 3, the first thing we want to do is find that LCD. So the denominators I have to choose from in this one is 2x minus 1, I have an x, and then again I have 2x minus 1. So my LCD is going to be x times 2x minus 1. I want to set this equal to 0 to figure out what values of x I'm not allowed to have. So I can't have x being 0, and x can also not be 1/2. And so we just set this aside and we multiply every single piece by my LCD. So I have x times 2x minus 1 times 2x over 2x minus 1. I have x times 2x minus 1 times 1 over x. And I have x times 2x minus 1 times 1 over 2x minus 1. And so when I cross multiply, a lot of stuff is going to cancel. 2x minus 1 will cancel in the first one. The x is going to cancel in the second one. And 2x minus 1 is going to cancel in the third one. And so what I have left over on the top is x times 2x plus 2x minus 1 times 1 equals x times 1. And so we can simplify this, and we're going to get 2x squared plus 2x minus 1 equals x. Now, because this is quadratic, the way we're going to solve this is by setting it equal to 0 and factoring. So first things first is I need to set this equal to 0. So I am going to subtract x from both sides. And so on the right it ends up canceling. And we end up with 2x squared plus x minus 1 equals 0. The left-hand side is going to factor as x plus 1 times 2x minus 1 equals 0. And we want to set each piece equal to 0 and solve. So we have x plus 1 equals 0 and 2x minus 1 equals 0. And so the first one's pretty easy. We're going to subtract 1 from both sides. And we end up getting x equals negative 1. And in the second one, we're going to add 1 to both sides. And so we end up getting 2x equals 1. And then we need to divide by 2. And so we end up getting x equals 1/2. Remember, you always have to double check with your little thought bubble you created at the beginning of this. And so I said that x was not allowed to be 0 or 1/2, but one of my solutions was 1/2. And so I am going to discard this one, but the negative 1 is completely okay. And so my final answer is just x equals negative 1. And let's go ahead and try one more. We have 2x over x minus 3 plus 6 minus 2x over x squared minus 9 equals x over x plus 3. The first thing we need to do is we need to factor the denominators. We didn't have to worry about this in the rest of them because they were already as simplified or factored as they get. And so the only one we really have to factor is the x squared minus 9. And that's a difference of squares. So it's going to factor as x plus 3 and x minus 3. And this will help us find our LCD. Our LCD is going to be x plus 3 and x minus 3. And so I have two values of x I can't have because they would create 0 in the denominator, and that's 3 and negative 3. So I'm going to multiply every single piece by my LCD of x plus 3, x minus 3. We have x plus 3, x minus 3 times 2x over x minus 3. I have x plus 3 times x minus 3 times 6 minus 2x all over. And to make this easier, I'm going to write this in its factored form, which is x plus 3, x minus 3. And the last one, we have x plus 3, x minus 3 times x over x plus 3. And so this looks terrible, but a lot of stuff is going to cancel to make our life easier. So the x minus 3 cancels on the first one. In the second one, both x plus 3 and x minus 3 cancel. And x plus 3 and x plus 3 cancel. And so what I end up having left over, in the first one I have 2x times x plus 3. In the second one I just have the numerator, which is 6 minus 2x. And in the third one we have x times x minus 3. And so we just need to simplify this and solve. So in the first one I'm going to distribute the 2x to both pieces. And on the other side I'm going to distribute the x to both pieces. We have 2x squared plus 6x plus 6 minus 2x equals x squared minus 3x. Well, on the left-hand side, we have some like terms we can combine. We have a 6x and a negative 2x. So we have 2x squared. Our 6x and negative 2x gives me a positive 4x plus 6 equals x squared minus 3x. And because this is quadratic, we want to set it equal to 0, factor, and solve. So the first thing I need to do is set it equal to 0. So I'm going to subtract x squared from both sides. And I'm also going to add 3x to both sides. And so it ends up canceling on the right. And what I have left over on the left is x squared plus 7x plus 6 equals 0. And so now we want to factor this. And so this is going to factor as x plus 1 times x plus 6 equals 0. We're going to set each piece equal to 0. And then solve them individually. On the first one, I'm going to subtract 1 from both sides. And we get that x equals negative 1. And on the second one, I'm going to subtract 6 from both sides. And we get that x equals negative 6. Remember, you always have to double check to make sure none of these were the values you weren't allowed to have. And the only two values we weren't allowed to have were 3 and negative 3. And since neither one of these is 3 or negative 3, they're both good solutions, and so we keep both of them. So our solutions are negative 6 and negative 1.